Now, since we have talked a lot about the area under the curve, about the distance, so I'm going to write the definition of definite integral. The details are written on the papers. I'll just explain it. The definite integral a to b f of x dx equals to limit n approaches to infinity. The same formula, summation I from 1 to n f of xi steric delta x. And you know what xi steric means. Xi steric means that you are not bound to stick to the left or right endpoints. If xi minus 1 and xi is the interval, the given interval, then you can pick up any value between them and we say that is xi steric. So the value of the function at any xi steric into the width of the interval for all the intervals together and applying the limit is actually equal to the integral of that interval from a to b, the total interval, integral from a to b, the value of the function at that end points. This is the lower limit, this is the upper limit, and this guy is an elongated s. This is actually s, but you stretch it a little. So when you stretch your s like this, it becomes an integral, and the person behind this stretching was Leibniz. So he named this symbol for the integral, and he said instead of this whole thing, which is same both on the left and right, you can say both are equal. But in this case, the margin of error is less. In this case, the margin of error depends on delta x. In this case, you will only apply the limit for the initial point and the final point in the function, but the condition is that this function should be continuous. This function should be differentiable. If your function is not following certain rules, if your function is not continuous, then you cannot apply that this integral sign on it. So we are actually not dealing with those functions which are not continuous in this single variable calculus. We will just talk about only the functions which will follow the rule of the integral. Anyways, this is called the lower limit, this is called the upper limit, this sign is called the integral, this is the integrand on which you are going to apply this operator, and on the right side you know this thing. Now I am going to tell you that this is the integral, definite integral. Then what is this? This is later on named as Riemann sum, and this is Riemann sum, and this is integral, definite integral. Now what will be the difference between them? The difference between them is, I'm going to tell you, if I have this curve and I want to know the area, this part, the area of this part, then according to this formula, what I will do? Come on, why you exit if you don't want to sit? Now, using the Riemann sum, so you should be clear enough. The first concept which we were talking about, the area and distance, is now known as the Riemann sum. So if in a question I ask you find the Riemann sum, you simply need, I will tell you whether left endpoints, right endpoints are the midpoints. You just need to find Rn, Ln or Mn. If I ask you using the left endpoints find the Riemann sum of this function for this interval, it means you are supposed to find Ln. If I ask you find the Riemann sum using the midpoints, then you will find Mn, the same procedure. But now this guy has a name and this name is Riemann sum. And this thing is called the definite integral. The definite integral means it has a certain limit, starting from a limit, ending at a limit. Now what is the difference between them? The difference is, if I am interested to know the area under this curve, then using Riemann sum, I know that I will split the regions depending on my delta. I will split the regions and I will make the triangles. If I am using the right endpoints, I'll make the triangles like this. And now these are, if say this is area 1, area 2, each rectangle has area. Then Riemann sum says that sum of areas of all these rectangles is equal to Riemann sum. And integral guy, now in that case, in the case of Riemann sum, the margin of error is depending on the delta. The smaller these things you will take, the more accurate will be the result. The larger these two guys you will take, the more error will appear. Now, what is this? Then what is the definite integral? The interval is same, a to b. Now, in the case of definite integral, the interval and the curve same. And I am again interested to know this area under the curve. But the definite integral will give me only this area under the curve. Integral from a to b, f of x dx. Only this. So in the case of definite integral, there is no additional parts, that small delta x, which was coming because of the sum of the rectangles. So this additional part was coming because of the sum of each rectangle. This was coming in the Riemann sum. And after Riemann, when we introduced the integral, now we have get rid of this smaller part. We don't need to do that. And when we will apply this formula, we will exactly get this area under the curve. So the definite integral means area under the curve. Now you should be clear. And the Riemann sum means sum of the areas of approximating rectangles. Both are giving me the areas, but this guy has more error depending on the delta x, and this guy has less error depending on the dx and the endpoints and the flexibility of the function. So the improvement came that you improved the calculation from here to here with a big margin of delta x. Anyways, so this is the difference between that and the definite integral. This guy, later on we will know how to calculate the definite integral directly using the same formula, just like we were calculating the derivatives. So still we are not at that stage. Still we will use the benefit of these guys to find the interval. But up till here, if I ask you, give me the integral of a function, then up till now and maybe next 1, 2, 3 lectures, you are not allowed to use the direct integral formula. So consider yourself that you don't know the direct calculation of integral. Maybe some of you know already, just like when we were using the definition of the derivative, we were assuming that we don't know how to calculate the derivative directly. If I say find the derivative of x square, then you can find simply directly it is 2x by using that formula, which is if you have xn, then the derivative will be nx power n minus 1. So you can calculate it directly, but before that I told you that we are not aware of this formula so far. So we were using the concept of definition f of x plus h minus f of x divided by h. Same is the case here. Up till now we are familiar with the name of definite integral, but we are not familiar what is the direct formula to calculate this integral. So whenever I am asking you, until we get to that formula, whenever I ask you find the integral of this function, you will say, okay, the integral of this function for this domain is equal to the Riemann sum of this function for this domain, and then you will calculate the Riemann sum and you will tell me, okay, the approximate answer of this integral is this guy. So we just introduced this integral. So do not, I'm telling you again, in this week homework, do not try to give me direct calculation of the integral. Keep this thing in mind. Whenever I will ask you find the integral, use this Riemann sum because they are approximately equal to each other. Detailed, I have written a lot of theory. You can read it if you are interested. If you will read it, it will be good for you. If you will not read it, it will be good for me. I can feel you. Got it?
Yeah.
Good. Good. Okay. So in general, just remember this in general, that integral a to b f of x dx is equal to limit n approaching infinity summation I from 1 to n f of xi delta x. So if somebody is interested to know this guy using the midpoint, he will tell you. If right endpoints, he will tell you. If left endpoints, he will tell you. In general, just write this. No need to put steric on it. So this is the general formula. On the right hand side, this is the Riemann sum. On the left hand side is the definite integral. Now let's do an example. Okay. Evaluate. No, the first part is express. Okay. Express limit n approaching infinity summation I from 1 to n xi cube plus xi sine xi delta x in the form of definite integral for the interval 0 and pi. So now actually he has already given you the Riemann sum total expression, and he's just very simple question. He's just interested that you give me the equivalent integral expression for this whole guy. So you just need to replace this thing for the integral. We said that if you go back to the formula, we said integral a to b f of x dx is equal to limit n approaching infinity summation I from 1 to n f of xi delta x. So what is happening? This delta x is replaced with dx. The function f of xi is replaced with f of x, and this whole thing is replaced with the integral symbol. So it means whatever will be here, I can replace it with f of x. So if you look at this whole thing, this will go back to the integral, this will shift to the integral. This part is actually the f of x, and this is for the dx. So you can now simply write this thing in the form of integral. This guy will change the shape of integral. Now, in this case, you are talking about the number of intervals, subintervals, starting from 1 to n. And you are saying that the number of intervals are infinitely many. So this was the whole thing. In the case of integral, you do not talk about the number of intervals. You start from the starting point and end at the last point. So here, the starting point is 0. Ending point is pi. So this is the lower limit, 0. And the pi is the upper limit. So I have got one thing, and I get rid of this. So I can remove this, replace it with this. Now this whole thing is my f of xi. This is in the formula of summation. This thing is this. And I know that this can be replaced with f of x. So I can replace this thing with f of x and replace this thing with dx. Now what is f of x? If this is f of xi, then remove the I from everywhere, it will become f of x. So I can say integral 0 to pi, wherever there is I have to remove it. When I am converting from Riemann sum to integral, I will remove the I, because I was coming for the summation. So remove the I and it will become f of x. So this will be x plus x sine x. This is f of x. I got it. Now dx I already have. So this is the definite integral expression for this Riemann sum expression. That is the only question. Is it okay?
Yes.
And we are not solving this. If you are interested to solve, I can give you as a question. And you know how to solve. Okay. If I ask you solve it, how will you solve it? If I ask you, okay, forget about this. The same function, and I give you that evaluate integral a to b, integral 0 to pi, the same function, x plus, what was it, x cube plus x sine x dx. And I told you that up till this week or maybe the next week, we don't know how to solve the integral directly. Even if you know, still we are assuming we don't know. So if I ask you evaluate this week, evaluate this integral, then what will you do? What will you do?
First of all, we'll make the intervals.
No, this is integral form. And I told you, you don't know how to solve this integral. But you know an equivalent thing which you can solve, and you can say, yes, this guy is
So
equal to...
we convert it into that form first.
Yes, so first you have to give me the Riemann sum form of this thing. So first you will convert this into Riemann sum, and you will say, okay, limit n approaches to infinity, summation I from 1 to n, and now this is f of x. So in this case you will add I, so it will become xi cube. Everywhere wherever there is x, you will add this I. So xi cube plus xi sine of xi into, now the dx will replace with delta x. So now I gave you this thing, you converted it into Riemann sum, Now you know how to solve this, the Riemann sum. You can assume any n. You don't need to separate the intervals. You know that what is delta x? Delta x is equal to b minus a divided by n. In this case, a is 0, b is pi. So pi minus 0 and divided by n. So it is pi by n. So this is delta x. So you can put it here, and at every xi you can replace it with what? You know that x naught is equal to the very starting point 0. x1 is equal to x naught plus delta x. X naught is 0 and delta x is pi by n. So it will be pi by n. x1 will be pi by n. x2 is equal to x naught plus 2 delta x. So it will be 0 plus 2 pi by n. So you can see x1 it is 1 pi by n. x2 it is 2 pi by n. If you are talking about xi, so xi will be what? Whatever is the subscript, this number will be the same according to these things. So you can say if this number is I, then it will be I pi by n. So this is your xi. Now you have xi and you have delta x. You can put these values, simplify it. It will be a big expression of n. You can apply the limit n, and you know how to solve a limit. If the limit is not solvable, you know how to make it solvable. If something is like n square plus 1 by n square, you know that you can write it as 1 plus 1 over n square. Here you cannot apply the limit. If you apply the limit here, it will become infinity, undetermined. No, but here you can apply. When you put n equals to infinity, 1 by infinity is 0, so you can get the answer. So do you know these things? But the first thing is, I gave you this expression in the form of integral, and I told you you don't know how to solve directly. So you will convert it into Riemann sum. Then what you need for the Riemann sum? You need xi, you need delta x. Delta x you can calculate from these 2 points. This is a, this is b. So delta x is b minus a over n. Pi minus 0 over n. Pi by n. So delta x is pi by n. And the parts x naught, x1, x2, so on up to xi. How to calculate this? You know this. X naught is the very first point. It is 0. x1 is the first point plus delta x. 0 plus delta x. You know this. Add them here. x2 is this. x3 is this. So you can get xi from here. So you have xi, you have delta x. Put them here. Simplify. You have done this in the homework. You can do it. Okay? If still you can't solve, then I cannot do anything. So there are some basic laws for the summation symbol, and some of them you already know. If you have summation I from 1 to n and the simple I like this, then what does this mean? It simply means when you put I equals to 1, it becomes 1 and there will be a plus because of the summation. Then 1 is gone, the next value is 2. So 2 into this, it will become 2 plus 3 plus so on up to the final value is n. So summation I, where I start from 1 to n, is always equal to this. But this thing, somebody has already proved that this thing in a shorthand notation can be written as n into n plus 1 divided by 2. So all these three are same. This is the same. This is the same. These two are the same. These two are the same. These two are the same. Everybody, they are equivalent. Similarly, now this was the simple when I power 1. If you have I from 1 to n, but the I has square power, it simply means, you know this. in the last lecture. It was 1 square plus 2 square plus 3 square plus so on, plus the final number is n square. And for the sum of first n integers, square of first sum of squares of first n integers, somebody has already given you a shorthand notation that it is equivalent to this thing. So if you have got some time, if you get this kind of expression, you can replace it with this. If you get this kind of expression or this kind of expression, replace it with this. And if you have a cube, I'm going to give you a question in the next homework where you will have a cube. So you will use this expression I from 1 to n, I cube. It simply means 1 cube plus 2 cube plus 3 cube plus so on up to n cube. Sum of cubes of first n integers. And somebody has already told us it is equal to n into n plus 1 divided by 2 and the whole square. Square on this whole expression. These were simple, but here this whole expression has a bigger square on them. Okay? And if you have summation I from 1 to n c, things like this, then it simply means then it simply means that you are adding this c n times together, because you have this summation n times 1 2 3 4 up to n. It means you are adding this c n times, c plus c plus c plus c. This is 1, this is 2, this is 3, and this is n. So you are adding them n times. What does that mean? It means this is n times c. So if you have summation, for example, if you have summation I from 1 to n 13, what does this mean? It means 13n.
13n.
So any constant, if it has this summation, then just multiply the n with it, because you are adding that constant n times because of this summation. And then if you have summation I from 1 to n cai, then you can write it as c summation I from 1 to n ai, because I told you that this I has the concern with all those terms where I is implemented. If there is no term having I, then you can simply multiply n with this constant and you can say okay, n times this. But if you already have some term I having I, then you don't need to keep this inside. You can keep it inside, it is your choice. But if you just keep it outside, still the answer will be the same. Do the things on this guy and just multiply it later on. So just keep it outside if it is a constant. If it is not a constant, then you are not allowed to take it, unless like if it is depending on this I, then you are not allowed to take it out. So you understand the difference between these two? 1 to n c. It was simple c and there was no other term having I. So you just got this n outside and multiplied with it, because this whole, as a single term, this whole thing means n. N times. Whatever is here, that guy will get n times addition. In this case, this term has I, so this term will get n times additions. You don't need to keep it there. Either you can write it, you can keep it, but that will be the trouble. If you want to keep it c inside, no problem. You can keep it there, c a1 plus c a2 plus c a3 plus so on c an. Now every time I had wasted a lot of ink to write this C, which I can take simply as a common outside, and I can work on this thing. That is the only purpose to write this rule, just for the simplicity. And if you have like this two expressions and they are adding together here in this summation notation, you can apply the summation on each of them separately. So it is summation I from 1 to n ai plus summation I from 1 to n bi. Now if you add the ith terms first and then apply the summation, or if you apply the summation on the first term separately, apply the summation on second term separately, and then add them together, answers will be same. If you do like this, let's suppose answer is 1600, then on the right hand side the answer will be again 1600. So sum of the summations or summation of the sums, answer will always be same. And if you have the difference formula, the same, but there will be a difference, ai minus bi, this symbol. So in addition and difference, you can always split the summation on like this. So you can apply the summation one by one each of them.